There's a question about the maximum height to which water could be raised in a tube, and it could be any liquid, of course, but the solution we do here doesn't assume any specific liquid, but usually it's going to be water. Okay, well, what's the maximum height to which water could be raised given a certain minimum temperature and maximum temperature? First of all, if you're raising water in the tube, if the tube has negligible volume, that is, if the tube is thin, then the volume is going to be constant, and the number of moles of gas in the in the bottle is going to be constant, meaning that P over T is constant, so that P2 over P1 equals T2 over T1. Little line of demarcation here. That Y max is not part of this. And you're trying to find the delta Y max, which is going to occur if you start at the low temperature T1 and raise to the maximum possible temperature T2. Now, in any case, P2 is then, if we assume that the initial pressure is that of the atmosphere, P1 is atmospheric pressure, P2 will be atmospheric pressure times the ratio of max to min temperature. And that is the case in the situation that we're talking about. So, you have two things going on here. You have one expression for P2. You have an expression for the change in pressure. That's just rho g times delta Y max. If delta Y max is the maximum height of this and T max the maximum temperature, then this delta P would be added to your atmospheric pressure to get P2. So now P2 is atmospheric pressure plus rho g delta Y max. It's also equal excuse me, to atmospheric pressure times the ratio of maximum to minimum temperature. Now we have the equation. First of all, we're looking at it as delta P. Delta P is P2 minus P atmospheric, which is going to be atmospheric pressure times maximum temperature over minimum temperature minus 1. In other words, we just take this expression and subtract atmospheric pressure, atmospheric pressure, and factor out the atmospheric pressure. We get this. So that the delta P being rho g Y max is equal to this, and delta Y max, well, you get that very easily by dividing this by rho g. Now, if maximum temperature is 400 Kelvin, minimum is 300 Kelvin, and of course we have to use absolute temperatures, then T max over T min minus 1 is going to be 1/3. And it's going to be 4/3 minus 1, which is 1/3. So the maximum pressure is going to be what? It's going to be the 33 kilopascals you need to raise water to this height, and you can work that out very easily, added to the 100 kilopascals of atmospheric pressure, so that your delta Y is going to be 133 kilopascals divided by your rho g. For water, rho g is 9,800, approximately 10 kilonewtons per cubic meter, giving you 1.33 meters of height in this specific situation.